Today we're going to be looking at Section 10.2, Rational Exponents. On example 1, we use radical notation to rewrite each expression. 9 to the 1/2 is the same as the square root of 9 because anything raised to the 1/2 means it is the square root. The square root of 9 is equal to 3. 125 then raised to the 1/3 means to take the cubic root of 125. It's 5 because 5 times 5 times 5 is 125. Then x to the 1/5 is simply the 5th root of x. We have to be careful on the next one because that -4 is not in parentheses, so the negative stays outside of the radical, and we have a negative square root of 4. We know the square root of 4 is 2, so our answer ends up being a -2. 2y raised to the 1/3, again, there's no parentheses around the 2y, which means the 2 stays out front. And we have simply y to the 1/3, which is the cubic root of y. So our final answer is 2 times the cube root of y. On example 2, we're using radical notation to rewrite each expression and to simplify if possible. The first one is 9 to the 3/2. We know that anything to the half is a square root, so we have the square root of 9, and the top number means that it is cubed. We know the square root of 9 is 3, so we have 3 cubed, which is 3 times 3 times 3, which is 27. 125 raised to the 2/3 means we have the cubic root of 125, that quantity squared. We know the cube root of 125 is 5. So 5 squared then is 25. So our final answer is 25. Again, we have to be careful with our negatives. The negative is not in parentheses, so it stays out front. We have the cubic root of 8, the whole thing squared. We know the cubic root of 8 is 2. We're going to square it, and we get 4. But we still have that negative out front, so a negative times that 4 makes it a -4. The next one, we have 2x minus 5, the quantity, raised to the 3/5. To write that out, we know the bottom number is the root, so we have the 5th root of that stuff cubed. So our answer is the 5th root of the quantity 2x minus 5 cubed. On example 3 then, they're asking us to write each expression with a positive exponent and then simplify. So when we have negative exponents, we can think of that as the negative does not make our number negative, it simply puts it under 1. So now we have 1 divided by 16 to the 3/2. Rewriting 16 to the 3/2 as the square root of 16 cubed, we know the square root of 16 is 4, and then we do more math. 4 cubed is 64, so we find our final answer to be 1 over 64. 125 raised to the -2/3, again, that does not mean the answer is negative, it means that it goes under 1, so we will do that. We have 1 divided by 125 raised to the 2/3. We know that 3 on the bottom tells us the root, so we have the cubic root of 125, and the 2 on the top simply means we square that. The cubic root of 125 is 5, and it's squared, so we'll go ahead and do 5 squared, and we get 25. So we have our final answer as 1 over 25. On example 4, we're told to use the properties of exponents to simplify. So we have x raised to the 1/2 times x to the 1/4. And when we see them like that, we know we add exponents. And simply 1/2 plus 1/4 is 3/4. So we have x raised to the 3/4. 5 to the 1/3 divided by 5 to the 4/3. When we bring that 5 to the 4/3 up, it becomes a negative 4/3 exponent. So now we have the root 5 raised to the 1/3 minus 4/3. 1/3 minus 4/3 is a negative 1. 5 to the negative 1 is 1/5. 7 to the 3/8 simply raised to the 4th. We take 4 times 3 and we get 12, and our fraction ends up being 7 to the 12/8. 12/8 reduces because 4 goes into 12 3 times, and 4 goes into 8 2 times. So we end up with 7 raised to the 3/2. On example 5, we're using rational exponents to simplify. We have the 10th root of y to the 5th equals y to the 5/10, which we know if we take 5 into the top and 5 into the bottom, we get y raised to the 1/2. And we also know that y to the 1/2 is the same as the square root of y. On the next example, we have the 4th root of 9. We can write that as 9 raised to the 1/4. We then take 9 and make it 3 squared. 3 squared raised to the 1/4 is 3 to the 2/4. Continuing to reduce, we take 2 into the top and 2 into the bottom, and we get 3 raised to the 1/2, which we know is simply the square root of that base 3, so it's the square root of 3. Excuse me. Example 6, we are using rational exponents to write as a single radical expression. We have the square root of x, which we know can be written as x to the 1/2. We have the 4th root of x, which is x raised to the 1/4. We go ahead and add the exponents and we get x to the 3/4. Writing it as a radical, we know it's the 4th root of x cubed. Again, remembering that this is the root in the denominator, and this is what we're doing to the stuff. So that's how we got x cubed, and the root is on the bottom, so we have the 4th root of x cubed. The second example is the square root of 2 times the cube root of 3. The square root of 2 can be written as 2 to the 1/2. The cube root of 3 is 3 to the 1/3. Putting them over the same denominator, we end up getting 2 raised to the 3/6 and 3 raised to the 2/6. Pulling out the factor 1/6, we have 2 cubed times 3 squared, the quantity all raised to the 1/6. Well, we know that that is the root. We talked about that already. And here it is, the 6th root of the stuff inside, which is 2 cubed times 3 squared. We know 2 cubed is 8, and 3 squared is 9, and 8 times 9 is 72. So we end up with a final answer of the 6th root of 72.